In this lesson, we will explore an existing application and predict its behavior. In this section, we will explore the parts of a project. This is an example project in LabVIEW NXG. This section is the navigation pane. This is the Project Files tab in the navigation pane. The Project Files tab shows all the files and folders in your project. Each LabVIEW project has one LabVIEW project file, which has a .lv project file extension. A project can contain a DACMX measurement panel, which has a .task file extension. A project also contains VIs, which have a .gvi extension. LabVIEW programs are called VIs, which stands for Virtual Instrument. Every project contains a System Designer file. A project can also contain folders. To open a LabVIEW NXG project, double-click a .lv project file. On the left, we see the navigation pane, and we are currently in the Project Files tab. Notice that the files in the Project Files tab are also files on disk. This project contains a DACMX measurement panel task. This project also contains a VI, which is a LabVIEW program that I can run. In this section, we will explore the parts of a VI. A LabVIEW program is called a VI. A VI has a panel and a diagram. The panel is where the user can set values, run the VI, and view data. The diagram contains the code, which defines the functionality of the VI. Now, let's look at the VI panel. On the panel, you can use the toolbar to run the VI, view the panel and/or diagram, and zoom. The panel can contain controls and indicators. Controls are inputs. For example, the user can use this control to input the max temperature threshold to the VI. Indicators are outputs. For example, this VI uses these indicators to output the temperature, threshold exceeded status, and a message to the user. Now we'll discuss the following panel object data types. A numeric control allows a user to input a numeric value. Notice the increment and decrement buttons. A numeric indicator displays and outputs a numeric value to the user. In LabVIEW NXG, controls typically have white backgrounds, and indicators typically have gray backgrounds. A Boolean control allows a user to input a Boolean value, which has two states. For example, on or off, true or false, clicked or unclicked. A Boolean indicator displays a Boolean result to the user. A string control allows a user to input text and typically has a white background. A string indicator displays and outputs text to the user and typically has a gray background. Notice that string controls and indicators can also include a scroll bar. The array data type contains multiple elements of the same data type. In this example, the array is a collection of numeric elements. A numeric array can be visualized as a list of numeric values or as a plot where each point represents a different numeric value. The waveform data type consists of an array of data values, along with timing information like the start time and time interval between data points. Notice that the waveform graph indicator displays both the data values and the timing information in seconds. Hardware resource data types allow you to select the specific hardware resource you want to access. For example, you can use the DACMX task control to select which DACMX measurement panel task in your project to access. Or you can use the DACMX physical channel control to specify which DACMX channel you want to acquire data from. Or you can use the VISA resource name control to select which GPIB instrument you want to communicate with. To access the properties of a panel object, simply click the panel object, such as this numeric indicator, and the Item tab on the right-hand configuration pane will display the object's properties. For example, this numeric indicator has a property defining its numeric type as floating point, and another property that tells the numeric indicator to display 6 significant digits on the panel. Now let's explore the VI diagram. On the diagram, you can use a toolbar to run the VI, use some additional tools, and zoom. This panel has 1 control and 3 indicators. If we look at the diagram, we'll see those same 4 items shown as terminals. Terminals are the entry and exit ports that exchange information between the panel and diagram. The color and symbol of each terminal indicate the data type of the corresponding controller indicator. Nodes are objects on the diagram that have inputs and/or outputs and perform operations when the VI runs. You can click a node to view its configuration in the Item tab on the right. This diagram also contains 3 constants. Constants are items on the diagram that supply a fixed constant data value. Wires transfer data between diagram objects, and wires have different styles and colors to represent different data types. Here are some examples of how wires have different styles and colors to represent different data types. The context help is a very useful window to have open while you program in LabVIEW NXG. Show the context help by clicking this menu item or pressing Ctrl-H. The context help displays basic information about whatever LabVIEW object you hover your cursor over. To view more detailed information about an object, click the More Help link in the Context Help window. In this section, we will learn about data flow. LabVIEW NXG uses a data flow model for running VIs. The rules of data flow are as follows. First, a node can only execute when data are available at all its required inputs. Then, the node executes. Finally, a node supplies data to its outputs only after the node has finished executing. So it's the flow of data that determines the execution order of the diagram nodes. Therefore, a diagram can have simultaneous operations. In this section, we will discuss how to find example code. To find example code, go to the Learning tab and click on Examples. Here you can browse and search many runnable LabVIEW examples. You can start from a working example VI and modify it to fit your application needs, or you can also copy and paste code from an example into your own VI. In addition to the Examples tab, you can also browse the Lessons tab to find learning content on how to program. Let's try taking a look at some DAC-MX examples. When you click an example, you can go ahead and launch it and create a project. Here we have a project that also includes a workbook that can guide you through this example. Here we see several example programs that we can explore. Here we see a DACMX example VI, and we can see that it's completed, and also you can take a look at the diagram and explore it. You've completed this module. Here is a summary of what you've learned.